So I've come to realize that the last video I recorded did not record microphone, but it's all good. Today we're doing thermodynamics. Well, today I mean the same day. Respiratory system was like 5 minutes ago. So thermodynamics, let's briefly go over this. So 8.1, first law of thermodynamics, how do we get heat then? So the first law of thermodynamics states that you can only transfer energy, like you can't like create energy um, like you just can't make it out of thin air. It has to be like whoa, I'm geek, bro. It has to be like transformed, like it has to switch from one kind of phase to the other. So like it can only be, bro, there's like a word, transferred. It can only be transferred from one from the other. It cannot be brought up. So that might ask like, yo, how do we get heat? Well, heat is just the transfer of energy from chemical bonds to heat. So like fire, the chemical bonds in wood, to heat. So what is the system? System is the part of the thing that is under study. Surroundings are the things that surround the system, and then system plus surroundings, that results in the universe. So exo and endothermic reactions in terms of how the system will feel. Exothermic reactions release heat, hence exo, exit, the heat will exit, and you'll feel warm. Endothermic reactions are the complete opposite. You're going to feel cold because they're taking energy from the surroundings to use in the system. Like, for example, melting ice. You're taking energy from the surroundings. So if you have, let's say you have an ice cube in your hand, it's an endothermic reaction because you're going to take energy from your hands, like the heat energy from your hands, and it'll melt or overcome the intermolecular forces in the solid ice form to form liquid water, which is an increase in entropy. Look at me connecting all these terms. That's why you feel cold. So 3 types of heat transfer. There's conductive heat transfer. There's convection, which is the movement of air to make it warm, like a hairdryer. And then there is radiation, which is from the electromagnetic spectrum. Okay, so what is work? Work is work. Work is like work done on a system. What else is there to talk about work? It is the energy transfer by force causing a volume to change. So delta E is the internal total energy. That is equal to W plus Q. So heat plus work. Q, I said Q, right? Okay, how do we get positive and negative work? So positive work is when like we put work on the system, like the surroundings are putting work on the system. We're compressing gas. Now, negative work is when the system is doing work on the, when the system is doing work on the surroundings. So now the gas is expanding and it's pushing something away. So that's negative work because we're not doing work. We're like, work is like being reversed. So what is positive Q, negative Q, positive W, and negative W? So positive Q is positive heat, kind of. So when we have positive heat, that means that we're putting in heat into like the system. Negative Q is the opposite, where we're losing heat from the system. So like losing heat to this, we're losing heat from the system, like, so like we're not like we're gaining heat. Like if we're the system, if we're the surroundings, then that's the system is losing heat, the heat is getting released. I hope that makes sense. Anyways, so now positive W is positive work, like I said, and negative W is negative work. Positive W is the compression and negative W is the expansion. Word. Endothermic, exothermic, yes sir. Okay, so what is heat capacity? Heat capacity is the amount of energy, joules, required to change 1 gram of substance by 1 degree Celsius. Like to increase probably. I would say increase. Bro, my nose gets so dry, but it's looking kind of cold. Anyways, specific heat capacity of the same molecule depends on the phase of it. Liquid and solid are different. The heat capacity of frozen water is most likely different than why did I even say liquid water, perhaps? Anyways, how to find heat lost or heat gained from calorimeter. So the formula is Q, which is heat, is equal to mass of the sample, so M, multiplied by C, specific heat capacity, multiplied by change in temperature, the change in temperature, final minus initial. What is heat of fusion and vaporization? That is the amount of heat required for a phase change without a change in temperature. So if we were to say like, yeah, the gas changed to from gas to the gas changed to liquid, and then it also reduced a certain amount of temperature, then we would split that into two and then add them together to find the overall Q. So how do you find heat required for phase change without change in temperatures? Q is equal to mass times the phase change thing, phase change enthalpy or whatever. So the calorimeter formula, if you don't have the mass, like if you have the specific heat capacity of the calorimeter itself and you don't incorporate mass, and you're just gonna have C times T. I got tripped out on some practice questions because of that. So two elements that are exceptions to the standard state. So we got wait, let me just look at this. We got mercury. I think it's bromine or bromine maybe. Not too sure actually. Relationship between energy and entropy. Wait, I actually gotta figure this out. What are two... Bro, the first thing I search out, as I say what are, it says what are the symptoms of hantavirus, bro. Okay, what are two exceptions? What are two... Bromine and mercury. Is that what I said? Yeah, I think that's what I said, bromine and mercury. Okay, anyways. Relationship between energy and entropy. I don't really know what to say about this. Energy and entropy. Energy and entropy. Oh, okay, so if you have high entropy, that means you're more stable. That means you have less energy. Let me just ask that. If you have high entropy, then you have high disorder, meaning you are more stable, meaning you are less energy, question mark? Saying that there's nuances. It doesn't imply less energy on its own. So we have to take into account... I don't really know. What is the third law of thermodynamics? Wait, I don't even... Wait, so the first one is conservation of energy. The second one is the entropy always increases. The third one is, the entropy will get to zero at 0 Kelvin. Like, there will be no movement, so you can't have entropy. Like, the movement is like zero. Okay, yeah, I don't really know what I was talking about, relationship between energy and entropy. Perhaps I should watch that video, but I really don't want to load it up. Yeah, I'll figure it out later. Okay, so what is a spontaneous reaction? A spontaneous reaction is a reaction where the change in Gibbs free energy is less than zero. What do all spontaneous reactions do? They proceed on their own, perhaps. All my ops, they did. Shebang. How does delta G relate to K? That's a good question. Wait, let me figure out the... Spontaneous reactions increase entropy. Oh, that's a true point. All spontaneous reactions will increase the entropy because you're going from... Yeah, wait, why does that even happen actually? Why do all reaction increase entropy? Dude, that's literally what you said, but not all spontaneous reactions directly increase, but they always increase the entropy of the universe. Spontaneous reaction occurs because they increase the total entropy of the universe. Even if the entropy decreases, the surroundings entropy increases, making the universe. Yeah, I guess they just all increase entropy, I guess. So how does delta G, okay, so the formula for delta G, first of all, delta G is equal to H, so change in enthalpy, delta H minus T delta S. So there's different scenarios where you can have spontaneity or non-spontaneity. So for spontaneous reactions, you will always have spontaneous reactions with an exothermic reaction, so you have negative delta H, and a positive entropy change. So you're going to be negative, negative. So you have to have negative delta H, positive delta S for a spontaneous reaction to always occur. For a non-spontaneous, you need to have a positive delta H, so endothermic, and you need to have a negative delta S, so that you have positive, positive. So how does delta G relate to K? So if delta G is less than 0, that means the reaction is spontaneous. Therefore, K will be greater than 1 because the products are more favored than the reactants. If you have a greater than 0 delta G, that means it's non-spontaneous. So that means the reactants will be favored. Therefore, you'll have a K value which is less than 1 because it's products of reactants. So that's all for thermodynamics. I'll see you tomorrow.